This is information to get you started for Unit 6 Microcontroller Systems for Engineers. This is BTEC Engineering Level 3. First thing we're going to do is to have a look at Breadboard. This is a reminder, we've covered it in class already, but here are two examples of breadboards, and this is what we use to make the electrical connections to the Arduino, and you can use this for other circuits as well. Now, the thing to remember is that breadboards have different connections. So for these kinds of connections on this side, you'll see sets of 5 holes, okay, like there, running parallel to each other. And all these sets of 5 holes will be connected to each other. So if we wanted to make a connection between 2 pins or between 2 wires, we would plug in one wire here into this hole, for example, and then we could plug another wire into there. And this row of holes are all connected together. So these 2 ends of the wires would be connected. The other thing to remember is that there is a break across here. So let's use another color. So this whole section is a little bit of a channel or a break between 2 rows. So because of that channel, the rows up here are not connected to these 5 holes there. So there's a break there. Okay, same thing. These 5 holes are not connected to these 5 holes as well. So you have sets of 5 holes all the way across the top, sets of 5 holes here as well, and very importantly, you have holes going along this side horizontally. Okay, I'll give you an example here as well. Here's another example of a different report, and you have a whole set of holes all the way to the end. Not quite getting it on the pen, but you know what I'm referring to. And another parallel set down there. And these lines are separate from each other. Now, as you can see, you have indications, and you can use this as positive or negative power supply rails. Now, this is how we will use it in the connections, and you also have another set over here. Now, what do you notice about the this style of breadboard versus this style over here? Now, I'll just remove the lines that I've drawn so it's a bit clearer to see. Now, what do you notice about the breadboard on top and the breadboard below in terms of the rails at the bottom and at the top? And what you will notice is that for this one, the lines go continually, at least the markings here. If you like, the paint on the board are continuous, whereas here, the paint on the board has a gap there. And this is very important because you may pick up some breadboards where you will have this gap here, and some breadboards where there is no gap. And the thing to remember is that if there is a gap, that means this set of holes is separate again from this set, these rails. So for these, in effect, you can have 4 rails on top and 4 rails below as well. If you wanted to use this across the whole board, you would have to remember to connect a wire to jumper across from there to there, or from here to here, to make it continuous. Otherwise, it will be a break, and you will not have any connection from this side to this side unless you manually make the connection. Whereas for this type of board, you can see the markings go directly across. So for this, you have just 2 separate set of rails instead of this one on top here, where it is 4 sets of rails. Now, the way to remember your connections, or that it helps make sense of it, is that if we turn the breadboard below and we remove the thick double-sided padded tape, you will just see simple metal connections. Okay, so these are the clips. So these clips do the connections across all of these 5 holes. And as you can see, you've got clips going all the way across for the rails, which are these ones here as well. And so this is how we use the breadboard and how the breadboard does its connections. So remember to look out for the break in the markings there and to make your connections in the right way. Now, the next thing that we're going to do is try and get a sense of how to connect our circuit onto the board, especially with regards to the Arduino. So I'm going to draw a rectangle here, and this will represent my Arduino. Remember, the connections can be anywhere. This is just a representation of where it is. Now, for convenience, I'm going to make this connection to the top here, which I will do and call the 5-volt connection. And the one below here, this will go to ground. Now, at this level for this unit, ground, or GND for short, is the same as the negative. So for example, if you had the equivalent of a battery, this would be the positive and the negative of the battery. But because we're using a controller and we're doing a few other connections with it, we will use the convention of +5 going up there and ground for the negative equivalent. So we're only going to use the terms +5 and ground for the Arduino. Now, if you check the Arduino, you will find the pin numbers for all these connections. There is more information on the literature that you will have available, and also you will see it marked on the Arduino board. Now, for the first connection, I'm just going to do a drawing of our connection of the LED output to ground. So I'm going to do a connection there. It's come up very in straight line, and it's corrected that for me. But it's not always going to do that. Now, we'll connect that to a resistor and to an LED. Now, this is the symbol of an LED, and the LED will go to ground as well. LED should have a little arrow coming out. By way of reminder, that little arrow is a sign of radiation. So in our case, this is light, visible light radiation. It could also be infrared or even laser, but this will be a general symbol for an LED or a diode which is emitting some kind of radiation. For our purposes, it's visible light right now. For this resistor, we're using a 220 ohm resistor. Okay, sometimes because it's hard to find an ohm symbol easily, you will see sometimes printed out in different places, they'll just use the word R, 220R, which means the same thing as 220 ohms. For the Arduino, we can use pin 13 or some other equivalent digital output pin. Pin 13 already has an LED on board. It's a small LED, which is kind of used as a test LED, so you can actually try it out without having to do any other connections. For this one right now, I'll just say we'll use pin number 12 instead. Now, the way that we draw things in general is, especially for this unit, but in general, you'll notice that as we go towards the top of the page, or upwards if you like, it becomes connections which are more positive sometimes, and in many cases, as it goes to the bottom of the page, it is less positive, or if you like, more negative. Now, this has nothing to do with the actual electrical connections. It's just a way of drawing it so that it's easier to see and read when we look at the drawings. That's why you notice well, I've brought up my +5 to the top and ground to the bottom part of the page. Now, it's very handy if you're able to do the same thing on the physical board. That is, if we make this side the positive connections, okay, because it is towards the top of the board, and this side we would make it negative. Just to note that in more complicated electronics, you have positive, ground, negative as well, and you have sometimes different voltages, but we'll leave that aside for another discussion. So for this unit, all we are concerned about is that we have a positive, +5, and a negative, or we'll call this ground. Sometimes we will also call it 0 volts. So because +5 and the more positive, we're drawing it to the top of the page, we'll try and use the rails on top here for positive and the rails down below for negative. Now, which ones do we use? For positive, we have the convention or the common practice of using red. And for negative, we have the convention or the style of using black. Negative. Now, on our breadboard, very conveniently, we do have a red marking. We don't have a black marking, but if you notice, there is a negative sign here, and we have a blue. So, well, that's closer to black, I suppose, than a red. So we will use this blue line, blue marking, as an indication of the rail that we're going to use. Okay, in real life, that means we are going to use this top rail here as the positive or +5, and we will use this rail, bottom rail here, as negative or ground or 0 volts. Okay, and I'll just put negative here as well, so we just get a sense of we're using all these words together, meaning more or less the same thing, but for this unit only. Now, once we've decided that, that simply means that we would connect a wire from here to the negative of the Arduino, or the ground. Actually, it's called GND. So we look for GND markings on the Arduino board. And on the top here, the red will look and connect it to the +5 volts on the Arduino. And you will see +5 and ground. Well, it doesn't say +5, but it does say 5 volts on the Arduino, and that is where we will connect it to. The moment we do that, then we know we have all these connections across here in +5, all these connections down here as the ground or the negative. And try and keep to that as far as you can, because that will follow the drawings that we have over here. And it becomes very helpful to have your physical layout follow your drawings as much as you can. Now, you'll not always be able to do that, but if you can, try and stick to that, and that will save you a lot of problems later on. Right, now let's make our actual electrical connections to the between the Arduino and the board itself. So let's say this is pin 12 going out to the Arduino, and you may use a wire of ideally another color other than black and red, but sometimes you just have to use what you have on hand. So let's start our connection to hook up the LED to the Arduino. We've used, in this example, pin 12 to be connected to Arduino, and the circuit diagram shows us that pin 12 goes out to the 220 ohm resistor, and then to the LED, and then to ground. So always make sure you have your drawing next to you. Do not hook this up just from memory, thinking that you can do this completely in your mind, because it will be very likely that you make mistakes. And unless you are very well practiced, you will make mistakes when you do that. So let's see, pin 12 will go to a resistor, 220 ohms. So let's say we got the wire to pin 12, and we can connect it to any set that we want. I'll choose some random place over here, and let's say we'll move it up there. Now, remember, that means all of these 5 holes are connected. Since I've plugged my wire into here, that means I have a choice of 4 other holes to make this connection to pin 12. And I will, let's use this one here just for clarity, and I'm going to connect my resistor. So I'll connect a resistor here. It can be done horizontally, it can be done vertically, it's up to you. And I will connect it, again, random choice, to another set of holes over there. It could just have been the next set, as long as it is another set of 5. So this will be my 220 ohm resistor. And now the next one is to connect it to the LED. Reminder that LED actually has a polarity that's plus, or the anode, and that's minus, or the cathode. And in practice, you'll have an LED with one pin longer than the other. And the longer pin, and you'll also see the difference being a notch on the plastic housing, but the longer one will be the plus, or the anode, and the shorter one will be the minus, or the cathode. So it goes from here to the plus, which is the anode. So I will connect the longer one, the longer wire there. Okay, connect the LED this way, and then the shorter wire, shorter lead, beg your pardon, I will connect to another set of holes in there. So remember, for the LED, you must have your polarity correct. And finally, the negative, or the cathode, goes to ground. So I will choose any of these 4 holes in this set. I'll just choose this one, just anything at random, and I will get a wire and connect it to this row, which is my negative rail. So again, to use the right terms, this is my positive rail, or my 5-volt rail. Okay, and this is the one below here is my ground rail. So with my circuit diagram showing that the negative goes to ground, I've done my negative with a wire that goes to my ground rail. And that will be the connection for an LED. The next one that we want to do is to connect a switch. Now, the switch will be drawn in a slightly different connection. So we've got this, and we'll choose another one. Let's say pin 11, which is another digital pin, and we can use it as an input or an output pin. And the way that we are connecting our switches will be, so this is the 5 volts. We are connecting our switch, which will be a push switch. And remember, a push switch has this kind of symbol. And the other one goes through a resistor to ground. So my resistor is a little bit squishy there because of space. It's nicer to be able to draw a longer rectangle, but this will do. So we've got a switch there, and we have a resistor, and this is a 10 kilo ohm resistor. Now, to be fully detailed, I put 10 kilo ohm, but again, because the ohm symbol is hard to get on keyboards, in many times you'll see in printed form just the written 10K. And because it's a resistor, we all assume that we know that it's an ohms. It's written in ohms. So let's do the connection now. Let's choose a different color, shall we? Let's choose, what should we have? Purple. Now, for the purple, let's say we're going to connect it to pin 11. So the way that we do it is that we get a wire, and I'm going to connect it to this set of 5 holes. Okay, so that's this connection here. And here's a little tip as well. Sometimes if it can be helpful to, if you have a highlighter, just to highlight the connections as you go along so that you know that you've made the connection. The next one is the pin, the switch, which will go to the 5 volts. So depending on what switch we use, we have a set of either 2-pin or 2-lead or 4-lead switches. So right now I'll just show you the 2-lead switch. So I will connect one here, okay, 1 lead to this hole. This is the switch, and I'll show you that in the simulator a bit later on. And I will say, let's use this one over here. The leads may need a hole that's slightly nearer, but for clarity, I'm going to draw it a bit further away. So again, just to show that we've done this connection here. And now this other pin will go to 5 volts. So this pin sharing this row of holes, I can choose any of these other 4 holes, and I will say I'll use this one, and I will connect it to the 5 volt rail on top. So that is done. The next one is to connect the resistor, the 10 kilo ohm resistor, to ground. And so this connection here, this node, if we call it, because the node has all these connections together, so 11 goes to the switch, and it will also go to the resistor to ground there. So I will connect the resistor now here, okay, and if you want to make it easier, just use the resistor, since it has long leads, to connect it directly to the ground. And this is your 10 kilo ohm resistor there. Okay, and now we've done this full connection, and we're ready to use this for as a switch, which the Arduino can detect. So this is, in summary, a connection for your switch from pin 11 going through the switch to +5 or to the 5 volt rail, pin 11, through the switch to the 5 volt rail. Pin 11 also goes down through the 10K resistor to ground. So that's pin 11. All these holes are shared connections. So this will go through the 10K resistor down to the ground rail.